Hello and welcome. Hello and welcome, family. Today we are looking at the change of limit. Okay, we have already looked at the integration by substitution. And for the change of limit, it's nothing new. Okay, just that it works like the differentiation where we looked at um is it chain rule? Yes, we looked at chain rule where we said that if you have y equals x plus 2 to the power, let's say 10, it's difficult to expand this to differentiate. So you need to represent this one by, let's say, u. Then after that, you differentiate, then you substitute it back. That's what we were talking about. Is that okay? So back to business, looking at this particular question that is given to us. Evaluate So looking at this particular question, see, if you want to evaluate this, it will be difficult to remove the square root. So for you to do this, this is what you do. You say that let u to be equals to the 4x plus 1, the one under the root. Is that okay? Then when you finish doing that, you differentiate this, the u, the x, which will give you what? 4. Then here you make the x the subject. So for you to make the x the subject, if you make the x the subject, you get the x to be equals to 1 over 4 du. Is that okay? You do cross multiplication, then the 4 will come here. Now, what it means is that when I come here, but before I start, the reason why we are saying we are doing change of subject is that the 0, 2 here is for what? The x. But now we are using u. So here, when I come under the square root, I'm going to put u there. Once I put u there, this place is now also becoming the u. Is that okay? So the 0, 2 here have to also be changed. So what you do here is that you change them by using the equation that you just formed, 4x plus 1. So you say that when x equals 0, what do you get? So when x is 0, you have u to be equals to 4 multiplied by 0 plus 1. So u equals to 1. Then when x equals 2, what do you get? So you have u equals what? 4 multiplied by 2 plus 1. So u equals to 8 plus 1. U is equals to what? 9. Is that okay? So when I come back to this place, it means that my new limit becomes 1, 9, square root of u. Now the square root under it is u. And this, the x, is now 1 over 4 du. But remember integration, this 1 over 4, because it is constant, to come outside. The integral of 1 to 9. This square root can be written as power what? Half du. Is that okay? Very good. Now let's integrate this. If we integrate this one, we get u to the power 3 over 2 over 3 over 2. And the limit is 1 towards 9. I hope you understand why it's like this. Okay. So let me clean the top here. Okay. Now let's continue from here. So this is what we have. We have 1 over 4 u over 3 over 2, then 9, 1 to 9. Now this one, you know that these two will come and multiply this one. I have already been, or I've been doing this. So this will be 2 over 4 u over 3, 1 to 9. You know why it is so? Because if you have u divided by 3 over 2, so I have my u times the 2 will go to 3 will come here. This will give you 2u over what? 3. But there's 1 over 4 here, so that's why it's 2 over 4 here. Okay. So now that we have this, can do the substitution. So 2 over 4, u is 1, so 1 over 3 minus u is 9, so 9 over, sorry, the upper limit first. So the upper limit is 9, so it's supposed to be 9 over 3 minus 1 over 3. 2 over 4 is 1 over 2 multiplied by 9 minus 1 is what? 8 over 3. So our final answer becomes 4 over 3 square units. Is that okay? So this is how we go about it. Now let's look at the second example. All right, so example 2, you have to evaluate 1 to 3 of x over square root of x minus 1 dx. So here, because there's a square root here, it will be difficult for us to do. So we say that let u to be equals to x minus 1. Is that okay? So when we differentiate the u, the x will be equals to 1. So making the u the subject, sorry, the x the subject, have the u to be equals to what? Dx. It means that wherever we see dx is the same as what? Du. Is that okay? Very good. Now, also, we need to change the limits, okay? And for you to change the limits, what you do here is that when x equals 1, then my u will be equals to 1 minus 1. U is what? 0. Then when x equals 3, my u will be equals to 3 minus 1. So u is what? 2. This becomes my new limit, 2 and what? 0. Is that okay? Now let's also see something here. You realize that if I put the du here, and here becomes square root of u, still there will be what? X here, and this x don't have to be there. We can change this x to what? U. How do we do it? We simply come to this, let me name this one equation 1. We simply come to this equation 1 and make x the subject from here. So u minus u equals x minus 1. So if I take additive inverse by bringing the negative 1, you have u plus what? Plus 1 equals what? X. Means that my x is equals to u plus 1. So when I come here, wherever I see x, I put u plus what? 1 there. So now, my new limit is 0 and what? 2. My x is now u plus 1. My x minus 1 is u. But there's a square root there, so u. My dx is exactly the u. So you see, I've transformed everything from x to what? U. Okay. Now, let's integrate this one. You can split the numerator so that we have something like u over square root of u plus 1 over square root of u du. Is that okay? So you're going to integrate this one separately, this separately. And remember that if I'm to integrate this one, this is like u over u power half. So per indices, this can be written as u to the power 1 minus half, and this give us u to the power half. Is that okay? And let's also look at the second one. The second one is 1 over u to the power half. So per indices, this gives u to the power negative half. So these are the two things that we are going to get. So let's clean this. So, per what I just did, the whole of this is u to the power sign half plus the whole of this is u to the power negative half, then du. Now, if I integrate this with respect to u, it will be u to the power 3 over 2 over 3 over 2 plus this gives us u to the power half over 1 over 2. Is that okay? So this is what you are going to get. But remember this, I have explained this. These two come and multiply this, and these two come and multiply this. So if that is the case, you don't need to be writing this. You can go straight. So the 2 multiply this. So that here will be over what? 3. And the 2 will multiply this. Here will be over 1, but there's no need to write that. And remember, our limit is starting from 0 to 2. So now I'm going to substitute this upper minus or lower. So if I put 2 here, I'm going to have 2 over 3 multiplied by 2 to the power 3 over 2. Is that okay? Plus 2, then multiply by 2 to the power half minus 0. Minus 0, because if I put 0 here, put 0 here, everything will still be 0. So this is what we have. So we are having 2 to the power 3 over 2, then also 2 to the power 3 over 2. So now remember that this one is having power 1, right? So here, if the bases are the same and they are multiply, we add their power. So I can have 2 over 3 multiplied by 2 to the power 3 over 2. The same thing, 2 over 3, 2 to the power 3 over 2. So you see, this and that are the same. Can you see that? If this and that are the same, if this one and that are the same, then it means that I can factorize that one out, leaving, I can factorize 2 to the power 3 over 2 out, leaving 2 over 3 plus, here if I bring it out, it will leave it 1. So 2 to the power 3 over 2, 3, 1, 3 plus 2, 5. So 5 over 3. So this becomes the final answer to that question. Thank you very much for watching. Let's solve or give you this example so that you can try it at your own pace. And that example is at the beginning of the question. You realize that when I started, I listed some questions. There were 3. I have solved 2. I leave it 1. So try your hands on that. Thank you very much.